Okay, so welcome to today. We are continuing with our circle geometry class. Today we are going to be dealing with chord related problems. So for the first question, we have that a chord of length 16 cm is drawn inside a circle of radius. So let me just draw a circle first. Right, don't mind my rough sketch. This is a circle. Now we have that the chord is 16 cm. Now the radius, let's say this is the center of the circle. Now the radius is 10 cm. Calculate the perpendicular distance from the center of the circle to the chord. Remember, we can also have another radius here, still 10 cm. What we are told to calculate is the distance from this center to the chord. Now, one thing you need to know is that whenever you draw a line from the center to the chord perpendicularly, it will actually cut the chord into two. It will actually cut the chord into two. And when it cuts the chord into two, what we are going to be having here is 90 degrees. We are going to also be having 90 degrees. So we're going to be having a right angle triangle. So it also means that this 16 length of the chord, 8 cm would be here, and 8 cm would be here. So this will be 8 cm, this will be 8 cm. So I'm going to be bringing out one of these triangles. So I'm going to be having something like this. This is a right angle triangle. This is 10 cm. This is what we are told to find. We'll call it our x, and this is 8 cm. So how are we going to solve this? How are we going to solve this? There are so many ways to solve this, but one easiest way to solve it is using Pythagoras rule. Using Pythagoras rule. That's one easy way to solve it. For those of you that have idea of cosine rule, you can also use cosine rule to solve it. Is that okay? You can also use cosine rule to solve it. But we are going to be using Pythagoras to solve it. Is that okay? So what we are going to be having is that hypotenuse squared is equal to opposite squared plus adjacent squared. We can also make it this way. 10 squared, 10 cm squared, or 10 squared cm is equal to 8 squared cm plus x squared. It's the same thing. So when we try to solve through, this will give us that 100 is equal to, or 100 cm is equal to 64 cm plus x squared. I can bring my s squared, make it substitute formula. I will have s squared is equal to, this one will come over here. So I have 100 cm minus 64 cm, which will give me 36 cm. Now pay attention. If I have that, I have that x squared is equal to 36 cm. So I can find the square root of both sides. This square will cancel the square root. So I have that x will be equal to what? 6 cm. Square root of 36 cm. So my x will be what? That means the distance here from the center of the circle to the chord will be 6 cm. I don't know if you understand this, but I think it's quite easy to understand since you already know your Pythagoras rule. Now we'll go back to the second question, which is actually a very tricky one. The second question is tricky. So I'm going to clean this and try to draw the circle here so that I can actually go on to solve here. So we have that a center of a circle. We have a circle. The center is O. And there are two chords, according to what we're told. Let's say this is the chord. This is PQ. And there's another chord. Let's say this is the chord, and this chord is RS. And both have a length of 12 cm. 12 cm length. I'm just smiling because I can choose to solve this using a very, very long method, but it's something we can easily just know. I can use what I solved initially to the first example. I can actually go about it the same way to find it. So, okay, both of them are 12 cm, definitely. If the perpendicular distance of from O to chord PQ is 5 cm, that means from here to here is 5 cm. 5 cm. Find the perpendicular distance of O to RS. Now, there are different ways I can go about this, definitely. There are different ways I can go about this. I can choose to, this is 5 cm, right? Let me just say, first of all, I can choose to find what the hypotenuse is. Is that okay? And if I find out what the hypotenuse is, remember this one will give me 6 cm here, and this one will give me 6 cm here, right? So this chord will give me 6 cm here, and this other one will give me 6 cm here. So if I bring out this one, definitely, I'll have something like this. Let's call this x. I have 5 here, 5 cm, and I have 12 cm here. So at the end of the day, I'll have that x squared is equal to 5 squared plus 12 squared, which is the same thing as 25 plus 144, which is the same thing as 9, 6, 1, 1, 6, 9. Is that okay? So to find the square root, definitely. Is that okay? So I have that s squared, square root of here is equal to square root of 169. So this will cancel this, and I'll have 13. It means that my x is what? 13. Now, what I want to show you now is this. Since this is also 12 cm, and the radius, we find that radius is 13, I can also have that this will give me something like this. Let me just say something like this. Remember, it's going to be a right angle, right? And I'm going to be having 13 here. I'm going to also be having 6 here. If you still use Pythagoras theorem to find this distance from the center to bisect RS, the perpendicular distance from center to RX, you will still find out that it will give you the same 5 because this one gave you 5. So what I'm actually trying to say is this. If the chords are equal, then the perpendicular distance will also be equal. If the circle is the same circle, within the same circle of the same radius, if the chord are equal, then the perpendicular distance must also be equal. So at the end of the day, discover that this will also give you 5 cm. I'm sure you understand the class, and if you have any question, you can do well to drop it.